In this question, we're going to look at the probability, and we're going to look at a particular part of probability that's related to combinations and permutations. Now, correctly, this is called the hypergeometric distribution, or it relates to a thing called the hypergeometric distribution, which will come later on. But just in the short term, we'll actually just look at it as a basic probability question using combinations and the choose operator. So here's the question. A team of 5 is to be chosen out of 4 men, let's underline that, and 5 women. Okay. Now the thing about that is, first off, we have 9 people. Let's just keep that in mind. So 9 people altogether. Now, in how many ways can a team be chosen? So how many ways are there of picking 5 people from 9? Straightforward enough. That's a choose operator question. How many ways can the team be chosen if there are exactly 3 women to be included? So this is where things get more interesting. So we'll just sort of come to that now in a while, but we'll actually just start off by answering question 1. So we have 9 people, and we have to choose 5. Okay, a team of 5 is to be chosen out of 4 men and 9 women. How many ways can the team be chosen? Well, this is the choose operator. So 9 choose 5, and that is equal to 9 factorial over 5 factorial. 9 minus 5 is 4 factorial. Actually, just as for the sake of clarity, I'll write up the formula down here. So 9 choose k is you compute it as follows: n choose k is n factorial divided by k factorial times n minus k factorial. So that's what the n minus k comes from. 9 minus 5 gives you 4. So that's just to be clear about what we're doing. So let's simplify this. 9 factorial can be written as 9 by 8 by 7 by 6 by 5 factorial all over. I'm going to write 5 factorial here. We have 4 factorial by 5 factorial, so I'm going to write that 5 factorial over there. And we have 4 factorial as well. 4 by 3 by 2 by 1. Now, you can see pretty clearly that the 5 factorials cancel out, so that's okay. Now, what we could do is a bit more cancellation. So 8, we can cancel that out with 4 and 2. 3, we can cancel that out with a 6, leaving a 2. So we'll cancel this out here. We'll cancel the 6 out and replace it with a 2. 2 divided by 3 is 6. So we have a 2 by 9 by 7. So 2 by 9 by 7. Bit of calculator work. That works out to be 126. So that's the answer to the first question. Okay. So the next question is, the second question is, how many ways can the team be chosen if exactly 3 women are to be included? So what we're going to do is, first off, state that we have to pick 5 people. And if we are picking exactly 2 women, that means exactly 2 men. Okay. So we're choosing from women 5 women choose 3, and the men 4 men choose 2. Okay. Also, what we'll do here is we have two. This is a compound event. So we have two events. How many ways there of picking 3 women? How many ways they're picking 4 men? So what we'll use here is the multiplication rule, which I'll come to shortly. But it's just if you want to have a read up on your notes. For basic probability, the number of ways of picking women times the number of ways of picking men. Okay, so 5 choose 3 is, here we have 5 factorial divided by 3 factorial. This is the same formula again, so 5 minus 3 gives us 2 factorial. Okay, and we have 5 by 4 by 3 factorial. And again, I'm going to put the 3 factorial at the end just to make sure that make it clear that we're going to cancel it out. 2 by 1, that's 2 factorial, that's a 2 there. The 3 factorials cancel out. So we have 5 times 4 divided by 2 times 1, that gives us 20 divided by 2, that just gives us 10. For the men, we have 4 choose 2. And we have 4 factorial divided by 2 factorial. 4 minus 2 gives us 2 factorial as well. There we go. So we have 4 by 3 by 2 factorial over 2 factorial times 2 factorial. 2 factorial is 2 times 1. So we have, let's cancel out the 2 factorials there. Okay, so 4 by 3 divided by 2 factorial is 2 times 1. That's 4 by 3 is 12 divided by 2. And that's equal to 6. So how many ways we can, from the 5 women, there are 10 ways we can pick 3. Okay, and for each of those 10 ways, there is 6 ways we can pick 2 more men to make up the committee. So that's the multiplication rule. Multiplication rule. The answer is 10 by 6. So the number of ways is 60. So that's the answer to the second one. Let's just go back there and read the question. How many ways can the team be chosen if there are exactly 3 women to be included? Okay, so the answer there is 60. What is the probability? Just read the question there carefully. What is the probability that the team has exactly 3 women? Well, we know that there's the number of ways. So the probability, we'll call that 3W, 3 women, probability of 3 women, is the number of ways we can get 3 women, okay, when we pick 5, divided by the total number of ways we can pick 5 from 9. So I'm going to call that N total. Okay, so these are the N3W and N total. These are just the answers to the previous 2 questions. So the number of ways we can get 3 women is 60. The total number of ways we can pick 5 people from 9 is 126. Little bit of calculator work there. The answer to that, just bear with me, is about 48%, 47.6%. We'll call it 48%. Or no, I won't. I'll just call it 47.6%. Just a very simple bit of calculator work there. Okay, or in other words, 0.476. Okay, so that's the answer to the second one. Just divide the first answer by the second answer. A team of 5 is to be chosen out of 4 men and 5 women. What's the probability that the team includes no men? Well, we have no men. That means we have 5 women. Okay, so what we're interested in is the number of ways we could have 5 women. Let's use that notation we adopted there earlier. Our equivalently, that's equivalent to the number of ways you can have 0 men. Okay. 5. So we're choosing 5 women from 5. 5 choose 5 is 5 factorial over 5 factorial minus 0 divided by 0 factorial. 0 factorial is 1, so we have 5 factorial divided by 5 factorial. And that is just equal to 1. An important thing to remark here, I'll just write it up here, 0 factorial is equal to 1, always. Times the number of ways we can choose 0 men from 4, that's 1 as well. Okay. If you just sort of try and write it down, you'll actually sort of see that it actually works out. Rather than having 5 people, it's 4 people. So, the total number of ways, N5W, simply equal to 1. There's one way we can have 5 women. Now, just the answer to the question is the probability of 5 women. Sorry, actually the question asks is for no men, so I'll just write it like that. It's actually directly equivalent, but that's a 0 there. 0 men, that's equal to N 0 men, or in other words 5 women, divided by the total number of ways we can have 5 people picked from 9, and that is 1 divided by 126. And the answer to that, just get my calculator out, is 0.0079. As a percentage, not or as a decimal, 0079, or in other words, 0.79%, less than 1%. So that's the answer to that question.